So, hi everyone. I hope you still have some energy left. Right? It's been a long conference. It's been awesome. There's so much things that we all learned. Heads are full. I hope I can actually add to that quite a bit. I have too many slides, so I'm going to try to rush it and get everything through. The LLM stuff's at the end of the talk. You all heard so much about that. I figured that would be the easiest one to skip if I run over. Anyway, so to get started, before we actually dive into the cloud, I want to introduce you to this guy. His name is Harry. Harry is from a country called Traponia, and he's a really grumpy dude. And he's traveling through Germany, and in Germany, he gets struck by lightning. And then after that, it's basically Groundhog Day. So he repeats the same day over and over, and the only way to get out of that is to learn German. And you might have guessed it, this is a German learning course. We built that in 2009, 10, something. We started that. It has 100 episodes of about 5 minutes length with the animations and all professionally made, everything. Lots of games, different additional features like a vocabulary trainer, support for teachers, so where they get additional PDF documents to do the lessons and everything. Huge project. It's also fully editable for the content, right? So they had editors that wanted to drag and drop stuff around, the whole menu, everything in all languages, left to right languages, right to left languages. It was planned for 2 years. Back then, it was all mostly done in Flash, if you still remember that. I actually tried to run the software today, and there's no Flash player anymore. So anyway, it was supposed to be 4 developers, including me. I was only on for the back end. About 2 months in, for some reason, all the other developers were gone. I was left alone. And I figured, oh, this is a huge chance. I was 5 years into playing with model-driven architecture, if anybody remembers what that is. Essentially, domain-specific languages that are given to a template generator, and then it will generate lots of code for you. So I figured, hey, I'll just do what all these 4 people can't do now. I'll do it myself. I just generate all the code. I'll be really quick, and it's going to be awesome. So I really thought I was self-employed at the time, right? So I thought, this is my big breakthrough. This is going to be the awesome project that I'm going to show everybody. And then lightning struck. About 1 year in, we showed the editor app to the editors, and they hated it. It didn't do what they wanted to do. And seeing them work with it, I totally realized they were right. We hadn't done any user tests, right? So back to the design board. About 2 years in, we realized it doesn't scale well. It's too slow, especially for the internationalized languages. It didn't have all the features that we needed, so full rewrite. 2 years in, hurt a lot, you can imagine. And we finished in 2014. And I was burned out and about 45,000 euros in debt, and decided this self-employed thing is not for me. I'm getting a job. Why am I telling you all of this? I learned a few things. I don't actually need other people to screw up the code. I can do that. And with all my sights set on, I'm going to do it right? I still fucked it up. I also found out that the whole process of talking to people and interacting with others is much more important than the tooling. And I hate the generators now, for lots of reasons. I decided to instead go into reducing complexity, whatever I can do to do that. And my go-to tools for that are DDD and software crafting, so all the nice practices that we get from XP and so on. So, long story short, it's how I got here, right? If I hadn't experienced that horrible thing, I might not ever have tried out DDD and come here. And it's also the start of me being in employment and eventually ending up at AWS. So with that background, let's do a little disclaimer first, right? So AWS is a toolbox. So is every other cloud provider. It's my toolbox, right? So I'm not going to talk about Azure or all of the other ones, not because they're not there or I don't acknowledge they exist, it's because I don't know about them. That toolbox is really big. It has more than 200 tools in it, and all those tools have thousands of features. I'm not going to be able to cover all of that, of course. If I'm not talking about your favorite one, sorry. Let's find me in the hallway later. I'll probably have a comment at least. So why is the toolbox so big? It's because AWS, and this is intentional, wants to give you the best selection of tools so you find the right one to fit the job. And that's also how this talk works, right? So I'm talking about the cloud through the lens of DDD. There's other lenses. And there's tools that don't fit well with DDD, but do with other things, right? So anytime I say this is a bad idea, it's not a bad product, it just doesn't fit. Okay, so having said that, so this is how I work at my consulting job. Lots of sticky notes on walls. I learned from Alberto, lots of sticky notes. So at AWS, I was confronted with this, right? So I was used to doing architecture by drawing pictures on whiteboards and putting sticky notes and looking at concepts rather than product, network, whatever. So I got there, and it was pretty overwhelming, to be honest, getting started at AWS. So architecture actually translates to technical stack, artifacts, different products. Everything is distributed. Of course it is, right? And everything is an API, and everything is billed by consumption, and everything is ideally a managed service that I don't know what it does. Everything is serverless, ideally, and automated and secure. And it had about this effect on me. So I figured, how do I make this work for me, right? I have my tools. I have DDD, I have crafting. How can I make these tools work in a way that fits that? Or is there any way to fit that? And this is what I started with, of course, right? So boundaries, most important thing. And of course, we start with a bounded context. So just to repeat quickly, it's the most essential building block of a software system. It has much more aspects than just technical ones. It affects the social, it affects political things, and it should always be defined by a ubiquitous language. And we should assume that this is also true in the cloud, right? Even if the technology is vastly different, that should still be true. So, okay, so a bounded context is one possible technical version of a subdomain. There can be more than one per subdomain, but there shouldn't be one that spans several domains or several subdomains. If you're dealing with legacy, then you might be surprised. One team can own a bounded context. One team can own more than one bounded context, but one bounded context should not be owned by more than one team. And if I'm going to implement one, first thing that I have to consider is how is it going to be, what access patterns do I have? How are people going to work with this? Because it affects cost, most of all. So we have different runtime models. The simplest one would be spin up a computer, right? EC2 in our case. That's the simplest one because it doesn't do much for you. It allows you to run servers like it's last century, right? So you can deploy your own software on it. You can deploy different packages onto your system. all of these things, but you have to, right? It's your responsibility. So it needs maintenance. And it's quite difficult to scale them well because it's always per computer, right? You spin up another one, you double the full capacity. Which means it's also the most expensive way to work with the cloud. It runs all the time. You wouldn't believe how many people forget to switch them off, right? So if you're running an instance, your developers are going home Friday afternoon, the machine still runs Monday morning, that's about a third of your cloud bill there. So next would be managed app servers, right? So you can get, for example, a Tomcat running on a machine, readily deployed. Would still be expensive, would still need the scaling efforts, but it would need less maintenance. Containers. That's better. You have several choices of hosting, different ones from you install your own version of Docker on an EC2 instance to you get them serverless. You just say, I want this container, and it's spun up. They're less expensive because they can run multiple containers on one host. And they're easier to scale as well. That's good. And then there's serverless functions. They start, stop, and scale automatically. That's awesome, right? You only pay for when they run. It would be my go-to choice to build modern systems in the cloud, unless you have workloads that run for a long period of time or have very predictable access patterns. So you only need them Friday morning from 9 to 11. If we implement bounded context in these environments, for a monolithic app, it's clear bounded context is a module, a package. For a microservice, it's one microservice. How about serverless? So they're built by consumption, so that's important. They should only be running when I need them. So they have to be stateless and they have to be asynchronous. I have to be conscious that there's startup time required, so there might be some latency issues involved if they only spin up every now and then. Reason for that is because, well, a serverless function has an extension that connects to the rest of the environment, a runtime, and the function itself that are all spun up once. Then this state is frozen, and then the invocation happens. So whenever something is actually done by the user. That's the thing you build for, right? That's what you pay, the invocation. But the startup time, cold start time, includes this whole thing. Okay? Now, they also scale automatically if I want them to. So I should be organizing all the things that I'm doing in a way that can be easily parallelized. And they should be as small as possible because memory costs money and runtime costs money. And now, if you think, oh, that's cool, I'm going to use the smallest version possible for everything, that's also sometimes not right because you also build by the number of executions. So if you have very small data items and you have a lot of invocations, that adds to quite a bill. So in the end, sometimes clustering these things, batching them, and then processing a batch through the function is also a good idea. And we have to connect them somehow because a process goes through several stages usually. It's not just one Lambda, it's a couple. They have to have some connection in between. So we need message queues or an event bus. Okay, so if I'm implementing a regular-sized bounded context, that means it can grow very quickly to 50 to 100 resources that I'm using, right? So it's a lot more moving targets, parts that I need to control. It's not just one microservice or one container. How am I going to deploy that? It makes sense to separate them, right? To have one context here completely isolated from another one, because, well, security. If I get a breach in one of them, it's not going to affect the other ones. If something goes wrong, then I'm reducing the blast radius. I have less accidental side effects because somebody, for example, deploys a falsely configured security group in the same bounded context, right? And potentially, the deployments might be faster. They don't have to be, but if I'm having a very large configuration file that gets deployed, something goes wrong, then the rollback will take a long time, for example. If they're smaller, that makes sense. So keep them separated. How? Possibility number one, we put one bound context into a VPC. Right? So virtual private cloud, that's how we call our virtual network environments that are completely separate from others. VPC has one problem. You can't always use them. So some customers have policies that say only one VPC may be used per team, for example. Or if you're working with serverless functions, they don't actually have to be in a VPC. They could be without VPC. So maybe not that. Also, it might incur extra cost. We could do one account per team, or one account per VPC, per bounded context, I'm sorry. So separate the logical structure and make that attached to the people that are using it. That's actually not so bad, but spinning up accounts in a corporate environment is difficult, so you need an automation mechanism for that to happen in a good way. So usually we do landing zones with customers or account factories where that can be done in self-service. Having that platform to depend on also means I can't do it alone, right? So somebody has to help me do it. Keep that in mind for later. Of course, somebody's going to say, what about Kubernetes? Well, there could be one bounded context per deployment. That probably is not going to scale too well. There could be one bounded context or one team per namespace, so you can have multiple deployments into the same namespace, and that will then end up building your BC. Maybe not such a bad idea. Or you could have one cluster per team. How many people are working with Kubernetes? How many people work with one Kubernetes cluster for the entire company? Good. Platforms are a dependency, right? So if you're using the same infrastructure with your co-team from next door, you're bound to clash at some point. All right, so let's talk about boundaries some more. Bounded context, we've covered that. But bounded context cannot exist in isolation. In order for the whole application to work, we have to have communication between them. So we get all these nice integration patterns that you probably all know. And we have to implement them somehow. So that's a contract. It's a contract that I'm making with the team next door. And that contract regulates both the form of communication that we can have. Is it an API, or is it messaging, or is there any other form of communication? And it also affects the social dynamics. Right? So if I'm using the API of another team, then we need to negotiate when that API is going to change, how it's going to change, how that's going to affect my application, for example. So we need to use context maps to figure out what's appropriate for our particular situation and what particular contract we should be using. Now, an integration I can build in several different ways, right? So I already mentioned we can have interfaces, REST interfaces, for example, GraphQL interfaces, remote procedure calls, messaging, or domain events. We should use some formal method to actually make those contracts explicit, and we should use tests to make sure that they're not breached. Now, you can think of this as a version of hexagonal architecture, right? So my REST API is an adapter that connects to the next context. I find that useful. What more boundaries could we have? Modules, right? So inside of a Lambda function, are there still smaller parts? Yes, there are. They're classes or functions or layers. Layers is a concept where essentially you build a part of your Lambda to share with others, and then you import that when you deploy the next version. So the deployment gets faster, and it's a bit more easily, well, the code gets smaller. It's easier to handle overall. However, they're package dependencies, right? So they're essentially kind of like package dependency in Java, for example. So if you import them, then you incur a binary dependency. That means you're coupling things. And if you're coupling your code to a package that's been developed by another team, for example, that creates a social dependency as well. Now, inside of a serverless function, we have a source that generates an event that's going to be passed to a handler, and then eventually that handler is going to send a response. This is usually kind of how I think of what a single Lambda looks like, right? So we have a piece of code that does the setup, that wires up the dependencies. Then we have the handler that gets the event. Then there's a try-catch block. I validate the input that comes in. And then I'm calling the domain code. I have either a success or a failure case, and then that is returned by the Lambda as a response. So initialization, integration logic, then I'm calling the domain logic, and then more integration logic that sends the response. A Lambda function handler should take care of wiring the dependencies, take care of the event and error handling, and take care of the response sending. But the business logic should be somewhere else. So we have a context-specific layer, the domain core layer, and we have maybe some generic stuff that is being shared by multiple teams. For example, code that accesses other AWS services, or code that accesses Kafka. The things that we need to plug in the infrastructure, because usually it doesn't really make sense to have different ways of doing that between teams. Now, for a separate layer for the domain core, we should make sure that it doesn't have any dependencies on third-party code. And we also should make sure that the same domain code is only used within the same bounded context, right? I don't want any binary dependencies to my neighbor team. If teams share common layers, they should only be technical. But I find that it's always a bit of a trade-off. So if I do share code between teams, it usually means we have to coordinate in some way. So it's sometimes a better idea to have duplication than to actually have that dependency. But it's of course a decision that everybody has to make for themselves. Right, so some more boundaries. I really don't want any hard dependencies on other teams, right? I probably made that clear already. Not because I don't like them, but because, well, it leads to problems usually. We shouldn't be sharing infrastructure, most of all. And we should make sure that our infrastructure is maintained as code. Deployment pipelines also fit that pattern, right? So my deployment pipeline is also an infrastructure component, and it should also be maintained as code. Very often you have centralized teams that provide the deployment pipeline to the entire company. How many people have that situation? Does that work well for you? Right? My experience is most of the time the stuff that gets provided by the centralized team doesn't quite fit my use case. So I'm going to have to find hacks or some ways to go around what's being given to me. That's a situation you want to avoid, right? So also blast radius, that's a thing, right? So something goes wrong, I'm going to suffer from that. And huge YAML files that I have to maintain in some form. Now, it's a good idea to align that infrastructure with the bounded context as well, right? It should be maintained in the same code base. We should be using the infrastructure as actual code. I like that phrase from Gregor Hopi, like CDK, for example, where it's not a YAML file. It can be tested. It can be named. There's variables, there's loops, and all these kinds of things. You want to avoid to separate your application logic from the infrastructure logic. So keep them both in the same repository. They're part of the same concept. There's a lot of things to be said about security and IAM roles and privileges and all that. CDK, for example, will help you greatly with that. So I totally recommend you use those things. It's as easy as saying database.grant read or write, and then you give it a function. Otherwise, setting up those roles and privileges is a pain. But that, again, that should all be within the same bounded context, right? We should be managing that as a team. We should know which part of the bounded context needs those privileges. What about Kubernetes? Well, same is true for Helm charts, for example, or deployment descriptors. You can also use tools like CDK to create the Kubernetes deployments. So it doesn't have to be a different thing. Definitely prefer things that you can spin up yourself over having them spun up by an ops team, the Kubernetes service team, or whatever. And make sure that there's only one cluster per team. So in a local environment, that would probably be impossible, right? In a company that hosts their own data center, they usually have one Kubernetes cluster, or maybe 3. But usually, it's one team taking care of all the infrastructure. The cloud does that for you, so there's no restrictions on that. The cost overhead for having several clusters is minimal, so it makes a lot of sense to just have it separated, and when one cluster goes down, the others are still running. Kubernetes is highly available. I've heard that sentence from customers quite often, right? It never goes down. It does. It does. And when it does, it's catastrophic. Right, so before you jump onto Kubernetes, though, if you're starting fresh, consider using serverless technology instead, because the maintenance overhead is significant. Right, so shared deployment pipelines, right? It's okay to use common libraries, right? It's okay to have something that I can import if I want to, if I need it. It's not okay to have that mandated, and it's also best to extract it from existing projects. When you know something that worked well for one team or 2 teams, then to make that a common tool, rather than build from scratch and then hope it fits the purpose. That leads to the situation where it doesn't quite fit my use case, so I have to start tinkering with it. Don't enforce as a standard. That's super important because that stifles innovation, right? It's a toolbox you want to give, but it's not one you want to mandate. And self-service is a key to success, as always. Right. More boundaries. How about data? Everybody's talking about big data, right? So we have three kinds of data, roughly. There's operational data, what we need every day to run our applications, the stuff that goes through aggregates, for example. We have analytical data. That's the output that essentially goes into reports or graphs or metrics, that kind of thing. And then we have operationalized analytical data. Depending on what kind of data we're dealing with, that also means we have different choices to make regarding the architecture. So operational data should be or is generated by the applications that we're running, right? So it's tied to a bounded context. We should be avoiding central data stores for that and make sure that we embrace the eventual consistency that's essential outcome of that, right? So if we have multiple sources of data, they need to be synchronized in some form. That takes time. You can choose different persistent mechanisms. You don't have to have one database, right? So you don't have to always use a SQL database, for example. You can choose regarding depending on which kind of data you're working with. There could be stuff that pertains to a relational database, for example, customer data, accounts, addresses, things that usually don't change very often. There's unstructured data that we're dealing with. That could be stored in a key value store or in a document database. If you're doing high volume searches or text searches, then you might want an indexed search engine like Elasticsearch. And if you're dealing with machine signals, IoT or that kind of thing, then you want maybe a time series database. All those you can choose per bounded context. And it's built by usage, right? So you don't have to be afraid of having this huge database that you now have to manage and you want to make use of, like in the days of Oracle, right? And then finally, of course, you can use event stores. Now, operational data needs to be quickly available, right? It has to have low latency, otherwise your customers are going to complain. So if we're having all these different little parts that are connected via message queues that will then eventually call the database, and then the way it goes back, that will add up. So you're not going to have just a single piece of latency, you're going to have compound latency. When you build these systems, that needs to be kept in mind. So you might want to use a cache. And that adds additional complexity, right? Cache invalidation is always fun. You should be doing CQRS for sure, right? So separation of the part that writes to the system and the part that reads from the system. There's different ways of implementing that, and there's always trade-offs to be made. But what's for me really is important, there should always only be one component that actually writes, because otherwise you get into trouble with race conditions and all that kind of thing. However, the reading functions you can scale to infinity, which is pretty cool. And for most systems, actually, that's what you need. Now, for analytical data, that's a projection of the data that we're using in our application, right? So it creates artifacts outside of the rest of the application. They're usually used by business analysts. They're usually used for data science, maybe even for our maintenance teams when they look for trouble in the system. They all need data from everywhere, from all the systems, right? So all the bounded contexts generate some of that data, and it all flows together somewhere, ideally a brain. Now, those data sets have to be accessible in order to be used, and that access has to be governed, right? There's some data, credit card transactions or health data, for example, that not everybody is supposed to read. There has to be some permission checked before that. So that content also has to be documented and searchable, because if I only have a data set that's maybe 5 gigabytes of JSON, I have no idea what it's doing, or where it's from, or what it's being used for. So there has to be a combination of all of these things in order for the data to be useful inside of my organization. Now, if I'm going to do that in a centralized data lake, I'm going to incur a big dependency, and essentially I'm creating a global context for my entire company. And we all know how well that works, right? So data should be decentralized. And that data scope should align with the bounded context. So if I'm generating analytical data in my context, I'm responsible for giving access to that data to others. It's a team responsibility, and it should be done in self-service. So I'm providing an interface or some way for other people to get that data. That is called data mesh. And I highly recommend you all read the book by Zhamak Dehghani. Awesome book. Now, if I'm collecting all of that analytical data and I want to make use of it for machine learning, then that also becomes an issue of bounded context, right? So we're training from analytical data that's created in a specific context to gain a functionality that we can then implement into our application so it takes over some operational functionality. Same rule like the one before, right? If I'm going to be running that model with data that I created, then I'm also responsible for maintaining and providing it to others necessarily. How those models come about, there's maybe a bit of discussion there. You might have a data science team that provides the model, but as soon as you put it into production and it's operationalized, it's your responsibility again. Remember that models incur drift, so if it works well today, maybe in a couple of weeks it won't. That has to be monitored, and somebody has to be responsible for that. That's the team. I'm going to speed ahead a bit. Really important for me is the fact that machine learning is very often biased and unreliable in this case. If you don't know Abiba Birhane, I highly recommend you follow her. She has a lot of really great publications on this topic. We often forget this, right? Machine learning is very useful and it's the hot shit, but it's also something that we should be using with caution. And especially if we're doing it automated. Right, more boundaries. Low code, no code. Who's using something like that? All right, I see one hand. So I'm going to skip ahead in favor of the other stuff. Too long didn't read. Low code is kind of magic. It usually does CRUD. It's a good idea to use for prototyping. You shouldn't be using it for your domain code. Step functions. That's a very popular tool that is essentially a low-code tool. I realize that a lot of people like that, right? So you click, you have a visual workflow, and you get a lot of things done very quickly. However, it's usually based on events that are generated from technical items, right? So it's a change event in a database or something like that. It's not a domain event. So it kind of blurs the line between what should be your business logic and what's integration logic. And more importantly, you get your business logic all of a sudden in a visual diagram that runs in the console. So you don't have the same effect that we actually wanted to achieve with DDD, right? So keeping it separate, separation of concerns, having it very nicely decoupled from all the technical dependencies, and having it well tested. And that's my major concern with step functions. Testing step functions is hard. So my recommendation would be you may well use them, but put them in the adapter, right? So don't use them in your centralized, most important business logic. Right, so I'm going to skip this one. Hopefully I can do that faster here. What about Gen AI, finally? To me, there's three kinds. First, the one that we integrate into applications. Eric demonstrated that yesterday with this little chat thing that made decisions, right? That output stuff that we could integrate into our logic. Then there's the chat-like assistants like ChatGPT. And there's the ones that we integrate into our development tooling, right? So Copilot, Code Whisperer, that kind of thing. Now, for the application integrated ones, you might have guessed, same rules apply as for the traditional AI and ML. You're going to use a model inside of your application. You're going to be ending up responsible for it. Should align to the bounded context as well in that case. The data that goes into those models, documents, all the things that you train them with, somebody has to be responsible for curation, right? That should also be aligned to the bounded context, if possible. For the chat-like Gen AI, I see the biggest potential for us in DDD, right? Because it enables a lot of things that we've never been able to do before. We could have conversations with our domain. We could feed it with all the data that our customers have about their business, and then we could learn from that. We could verify that our implementation fits with the domain rules, right? So we could feed it our code and say, verify that this doesn't violate any business rules. We could have processing for visual models with the new Gen AI stuff, right? So we generate a large wall full of post-its, and then we could have it scan that and create code output from that, maybe, like Philip demonstrated very nicely yesterday. And it could, and this is, I think, is also very useful, explain the code that was written by others. And how many times have we done legacy refactoring, and there's a gazillion lines of code where nobody has written any comments. So that's very useful. However, these things have hallucinations. There's ways of tweaking them and making them better. We should be using them, like augmentation, right? Really training them with data that has been curated by people that know the domain. We should always verify the output. Never just blindly trust them. And it will never replace actual human collaboration. So even if we talk to that domain model and it gives us answers, we should probably also talk to the subject matter experts and verify that it's actually correct, or it covers all the bases. It can be quite costly to run those things. So use cost alarms. Make sure that you get an email when it hits $50 or something. And consider using faster, simpler models over the general purpose ones, the big ones that are very costly. Finally, code completion and integrated tooling. I find that the autocomplete-like features are really useful. I've been using them for a year now, and it feels very natural to me. So it integrates well with my train of thought when I'm writing code. They're promising to be better when we have versions of those that we can train with our own code, currently being developed. So that's going to come eventually, right? So we can use our own code base, the well-maintained one maybe, and then the output will become more like that. Really looking forward to that. Explain my code. Awesome for legacy refactoring. And then we have chat-like plugins, so a combination of the tooling integrated one and the general purpose chat. That's awesome for searching in documentation, for example. It will even give you Stack Overflow output. And who doesn't want that, right? But there's also a but. From mostly, it's not the tooling itself, but when you look at all the marketing content that is being generated to advertise for these things, they promote bad practices. You tell it what you want to do, and then it generates 5 classes, and you just put that in production, right? That's kind of like copying and pasting from Stack Overflow without actually understanding what's happening. You shouldn't be doing that. Generating unit tests, because I don't like to write tests. And then the test will look like test method A, test method B, test method C. That's not a good unit test. That couples the test with your implementation, and it doesn't verify that the intended behavior is actually being performed. Right? So you shouldn't be writing that kind of test automatically. And the same is true for documentation, like Javadoc comments. If you're going to generate them automatically from a model like that, it's going to be method A does this, but that's also the name of the function. So it's redundant. Redundant documentation you shouldn't be writing. You should think about naming your code better, right? Then you don't need all that documentation. So beware of these. Finally, I still think, even with all the new super great technology in the cloud, that business code should be encapsulated, it should be well tested, and it should not have third-party dependencies. That's possible. It just requires a bit of extra work. You should not blindly trust your business decisions to a Gen AI model, if I have to make that explicit. It's too important. At least verify. And this is important coming back to the very beginning of my talk. Our job should be to reduce complexity. And anytime we're doing things that generate lots of code that is unscrutinized, we're doing the exact opposite. We're creating more complexity. That's going to bite. It's going to do this. I know what I'm talking about. Thank you.